Hello students, today we are going to discuss the numerical of parabolic arch. Question is written as a three-hinged parabolic arch is shown in figure. Find the location and value of maximum positive bending moment. Now here in this diagram, a arch is shown, that is three-hinged parabolic arch having uniformly distributed load in the left span AC of magnitude 50 kN per meter and is having a central rise of 4 meter and the span length of 20 meter. Now we need to find the location and value of maximum positive bending moment. For finding the maximum positive bending moment, we need to calculate the support reaction, that is VA, HA, VB and HB. For finding the support reaction, we will use the equilibrium condition, that is all the vertical forces sum will be equals to 0, that is sum of all the forces in the vertical direction is equals to 0, that is VA plus VB will be equals to 50 into 10, because 50 kilonewton per meter of load is acting on a span of 10 meter. So it will be equals to VA plus VB will be equals to 500 kilonewton. That will be our first reaction. Okay. Now the second equilibrium condition is summation of all the forces in the horizontal direction is equals to 0. So we will write it as summation of all the forces acting in the horizontal direction is equals to 0. So HA will be equals to HB. That is our second equation. Okay students. Now our third equilibrium condition is moment about A will be equals to 0. So from support B we will take the moment about A equals to 0. So we will write the equation as minus VB into 20. Minus sign is because of anti-clockwise movement due to VB, plus 50 into 10 into 5 due to UDL, and it will be acting in clockwise direction. So we had taken the sign as positive, equals to 0. On solving this, we will get the value of VB equals to 125 kilonewton. That will be acting in the upward direction. Now from equation first, we will determine the value of VA as 375 kilonewton. It will also act in the upward direction. Now for finding the horizontal reaction HA and HB, we need to use the fourth equilibrium condition, that is moment about internal hinge C is equals to 0. Now we will write the equation from the right hand side. It will be equals to minus VB into 10 because of this reaction, that is VB, and it will be acting in anti-clockwise direction. So we had written the minus sign here, plus HB into central rise, that is 4 meter is equals to 0. On putting the value of VB here as 125, that is minus 125 into 10 plus HB into 4, we will get the value of HB. The value of HB is equals to 312.5 kilonewton in the leftward direction. Okay. Now from equation 2, we will determine the value of HA equals to 312.5 kilonewton in the rightward direction. Okay students. So we had determined the value of VA equals to 375 kilonewton, VB equals to 125 kilonewton, HB equals to 312.5 kilonewton acting in the leftward direction, and HA equals to 312.5 kilonewton acting in the rightward direction. Now we want to calculate the maximum positive bending moment, and we know that the maximum positive bending moment will lie below the loading. Okay, so we had considered a section XX in the span AC, okay, whose distance is x meter from support A and vertical distance is y. So we will write the bending moment equation about this x axis. Okay, So we will write here the bending moment equation about x-axis, and it will be equals to VA into x minus HA into y minus 50 into x by 2. Okay, so we will put the value of VA as 375 x minus 312.5 into y minus 50x square by 2. Now we know that the value of y for parabolic arch will be equals to what? It will be equals to 4hx upon L square into L minus x. So we will put the value of h and L here. It will be equals to 4 into 4 divided by 20 square into x into 20 minus x. That will be the value of y. So we will put this value of y in the equation, that is 375x minus 312.5 into, in bracket, 16 upon 20 square into x into 20 minus x minus 50x square by 2. On solving this, we will get the final equation as 125x minus 12.5x square. That will be the final bending moment equation about x. Okay. Now for maximum positive bending moment. We need to differentiate the equation of bending moment about x with respect to x. So its value will become 125 minus 25x. Now for finding the distance of the x-axis section where the maximum positive bending moment will lie, we need to equate this with 0. So by equating this value with 0, we will get the value of x as 5 meter from A. This is the distance at which the section XX will lie, that is from 5 meter from support A. Okay. Now putting this value of x in the bending moment equation, that is bending moment at XX, it will be equals to bending moment at x equals to 5. We will get 125 into 5 minus 12.5 into 5 square, and the maximum positive bending moment will be equals to 312.5 kilonewton meter. That will be the maximum positive bending moment acting at 5 meter from support A, and its magnitude will be equals to 312.5 kilonewton meter. That is all about this question. We had completely solved this question. Thank you very much, students.